Let's understand the difference between distance and displacement with the help of a diagram. So consider a particle is traveling along this irregular path and A, B, C, D are 4 points on that path. So in this situation, what is distance and what is displacement? Distance is the total path covered by the object. In this situation, the length of this path ACDB will be the distance. Distance is a scalar quantity, which means it only has a magnitude, it does not have any direction. Distance can never be negative. And why can't it be negative? Because distance is a scalar quantity, it's a positive number. The distances can, of course, be zero if the object is not moving, but the distances can never be negative. On the other hand, what is displacement? Displacement is the straight line which connects the initial and the final points. So in this diagram, if we connect A and B with a straight line, AB, length of this line segment AB will be the displacement. Unlike distance, which is a scalar quantity, displacement is a vector quantity, which means it has a magnitude and a direction. Magnitude will be the length of this line segment, and direction of displacement will be the direction of this arrow. Now, the most important aspect of displacement is it can be positive, negative, or even zero. We are going to discuss all these cases separately, but consider a special situation when the object is moving in a straight line. So the concept is distance and displacement both will be equal if the object is moving in a straight line. And please remember this fact as we are going to use this in a lot of questions. Now, coming to the types of displacement, how can it be positive, negative, or zero? So, positive displacement means object is to the right of the starting point. So, let us consider a few examples. So, example number one, if the particle is starting from this point and it is traveling towards the right hand side, so end is to the right side of the start, this is considered the positive displacement. Let's consider another example. So look at this type of motion, how the particle is moving. So here the particle started from here, it went right and then it changed the direction, it went left all the way to this point and then again changed the direction. Finally, this is the end point, but ignore the entire motion. We only focus on where is the start point and the end point. So here in example 2, you can see that the end point is to the right side of the start. That is why this is also considered as positive displacement. Negative displacement, on the other hand, means the object is to the left of the starting point. So example number 1, this is the easiest case where the particle is just moving towards the left hand side. So end is to the left of the start point. Example number 2, so analyze this motion also. So like in the previous case, here also the particle is changing direction, but the end point is to the left hand side of the start point. So this is also an example of negative displacement. At the end, what is meant by zero displacement? It means the object is back to where it started from. Example number 1. So consider this. If the object goes to the right, left, and back again, so the particle has come back to the same point where it started from. This is an example of zero displacement. Another example will be a circular motion. So imagine the particle starts from here, it goes around this circular path and ends up at the same point. Now, since the particle is back to the starting point, we say displacement is zero. And that is why in the exam questions, if they specify positive displacement, negative displacement, or zero displacement, we should understand the basic implication. Positive displacement means the object is to the right of the start. Negative displacement means the object is to the left of the start. Zero displacement means the object is back to where it started from. Now, let's solve a question based on displacement. Here we have a car traveling clockwise around a circular track of radius r. What is the magnitude of displacement from x to y? So here the car started from the point x, it went around the circle in a clockwise direction and finally reached the point y. We need to figure out the magnitude of displacement. Now, if you recall what is displacement, it is the straight line which connects the start point with the end point. So let me draw a dotted line which connects x and y. So this will be that dotted line and we need to find the length of this line segment xy. And how do we find out this length? So consider this triangle, which is a right angle triangle. This angle over here is 90 degrees. Since the radius of the circular track is r, so now what we can label is this particular length is r, the radius of the circle, whereas this particular length is also r. Now we have a right angle triangle over here we have to figure out the length of the hypotenuse. So we will use the Pythagoras theorem. So let's write down the value of xy, the magnitude will be square root of r square plus r square, which comes out as square root of 2r square. If we simplify this, we get r root 2 as the answer, which means option C is correct. Next off, we have a person, Samantha, walks along a horizontal path in the direction shown. The curved path is a semicircle. We need to find the magnitude of displacement from the point P to the point Q. Like we discussed, displacement is the straight line which connects the start point to the end point. Here, the start point is P and the end point is Q. So let's connect P and Q with a dotted line. So first of all, this entire length from Q all the way till point P is the magnitude of displacement. So let's label this point over here. Let me call this point as R. Now, the total displacement will be the length of PR plus RQ. Length of PR is already mentioned as 4 meters. So let's write down PR is 4 plus. What is RQ? RQ length we need to figure out. It's mentioned in the question that the curved path is a semicircle, which means we can say that QR is the diameter of the circle and the length of the diameter is double the radius. So the radius of this circle is 2 meters. So the diameter will be double of 2, which is 4 meters. So QR length will be 4 meters. So PR plus RQ will come out as 8 meters. And hence we can select option D as our answer. Now let us discuss the difference between speed and velocity. Like we earlier we discussed the difference between distance and displacement. So what is speed? Speed is the rate of change of distance and the formula for that is distance upon time. So in this diagram we saw distance traveled is the length of this irregular path. So ACDB, the length of that will be the distance. Hence that is the numerator and time will be the denominator. So speed is the rate of change of distance. Velocity, on the other hand, is the rate of change of displacement. And in this case, we saw displacement was the straight line which connects the start point A to the end point B. Hence, velocity is displacement divided by time. Displacement was AB and T is the time. Now, in the exam questions, a lot of times they will ask, what is the average speed? What is average velocity? So for questions, we need to remember the average speed is nothing but total distance traveled upon total time, and average velocity will be the total displacement divided by total time. Sometimes the questions might ask you, what is the instantaneous speed and velocity? So what is meant by these two parameters? So instantaneous speed is the speed at a particular instant. Similarly, instantaneous velocity will be the velocity at a particular instant. Now, remember, speed is a scalar quantity, it only has a magnitude, but velocity does have a direction also. And how do we find the direction of instantaneous velocity? So, you need to remember the direction of instantaneous velocity is found by the tangent at that point. For example, if we consider this path, if the question asks us to find the direction of velocity at the point A, all we need to do is draw a tangent to this path at the point A. So, this particular orange arrow will be the direction of instantaneous velocity at the point A. Similarly, you can consider any point and draw a tangent at that. That will give us the direction of instantaneous velocity. Let's solve a question based on average speed and average velocity. So here it's a graph-based question. The y-axis is displacement, x-axis is time. The question is, what is the average speed and average velocity? Average speed is total distance divided by time. Average velocity is total displacement upon time. So in questions like this, it is easier if you start with average velocity. Average velocity is displacement upon time. So at time t is equal to 0, displacement is 0. And at time t is equal to 10 seconds, we can see the displacement is 8. So let's write down the formula for velocity. Average velocity is displacement upon time. Total displacement is 8 and total time is 10. So this comes out as 0.8 meters per second, which means the answer is either A or C. Average speed, on the other hand, is the total distance divided by total time. So in the graph, we saw the object was at the 0 marker at t is equal to 0 till 8 seconds. You can see the displacement of the object is continuously increasing. Let me try to represent this in a diagram. So let's say the particle starts from t is equal to 0 from this point x. It starts from the 0 point. So this is x is origin. Then the particle starts to go towards the right hand side till it reaches t is equal to 8 seconds. At t is equal to 8 seconds, you can see the displacement is 10 meters, which means the object is 10 meters away from the starting point. Hence, the length of this line segment from this point x to this point, this is 10. And then if you look at the graph carefully, after 8 seconds, displacement value is continuously decreasing. Now, the displacement is going to decrease in this situation only if it goes closer to the start point, which means it is going to reverse its direction and then it reaches a displacement mark of 8. What does that mean? The distance from the start point to the end point, this is 8 meters. And when the particle reaches this point, this is t is equal to 10. And average speed, if you remember, is distance traveled upon time. So the particle went 10 meters towards the right hand side and then it went towards the left hand side. So what will be the length of this small distance? It will be total 10 minus 8. So this particular length will be 2 meters. So let me write this is 2 meters. So let's write the formula for speed. Speed is total distance upon total time. So here the distance will be 10 meters plus 2 meters, which will be 12 divided by the time taken is 10. So we get 1.2 meters per second, and hence look at the options. Option C is the right answer.